Okay, so what we're going to do right now is I'm going to give you guys an introduction to the Fibonacci numbers. And it's easy to construct these numbers just with the basic idea of this bunny problem that he came up with. So what I'm going to do for this talk is I'm going to use this to represent one pair of bunnies. Now, normally I draw one bunny for each bunny, but the computer screen's kind of small. So it'll work better if whenever you see this symbol, you visualize a pair of bunnies instead of one bunny. So we have some rules to this word problem, and the rules are going to be, well, mature pairs of bunnies always reproduce, and they create one pair of bunnies in the next year. And baby bunnies mature in 1 year, and baby bunnies don't create any new bunnies for the next year. So these are our rules. And the question is how many pairs of bunnies will we have? Okay, well, let's try to take a look. So let's say in year 1, how many bunnies do we have? Well, I'm going to start off with one pair of bunnies. And we buy these baby bunnies. So they can't produce in the next year. So the next year I have, well, the same, one pair of bunnies. But now these are mature bunnies. So in year 3, what I get is I get my bunnies together with the new pair of bunnies, a pair of baby bunnies. Okay, and what I'm going to do is I'm going to draw a little line here. So these are the mature bunnies on the left and the baby bunnies on the right. Well, what happens in year 4? Well, the mature bunnies are going to produce another pair of babies, and the babies are going to mature. So we're going to have 2 pairs of mature bunnies and 1 pair of baby bunnies. Okay, but now for year 5, we have 2 pairs of mature bunnies. So our 2 pairs of mature bunnies are each going to produce a pair of baby bunnies, and our babies are going to grow up. So we're going to have 5 pairs of bunnies. That's not the most attractive bunny. 3 mature pairs of bunnies and 2 pairs of baby bunnies. Now in year 6, the babies are going to grow up. The mature bunnies are still around. Bunnies never die in Fibonacci's problem. So I get 5 mature bunnies. But you see, each of these mature bunnies in the 5th year, well, they're going to produce a pair of baby bunnies. So I get 3 babies. Well, let's try to count. We have 1, 2 pairs, 3 pairs, 5 pairs, and then 8 pairs. So let's try to figure out what's going on here. Can we figure out a formula so I don't have to keep drawing all these bunnies? And yes, what I notice is, well, the number of baby bunnies in each year is going to be equal to the number of mature bunnies from the year before. So the total number of bunnies are going to be, well, the babies from the previous year that grow up, together with the mature bunnies from the previous year that are still around, together with the new offspring from the mature bunnies. So these lines actually help us to see that. Notice that this first pair of baby bunnies, well, this was a baby bunny, but we started with that. But this first pair of bunnies that were born underneath our watch came from here. And this pair came from here. And these 2 pairs came from here. So, in every given year, we have the total number of bunnies from the previous year, together with baby bunnies equal to the mature bunnies from the year before. Okay, well, the mature bunnies from the year before, well, that equals the total number of bunnies from the year before that. So if I let's say, Fn be the total number of bunnies in year n, I get, well, the bunnies from the year before all live, but the new offspring, the baby bunnies, well, that's going to be f of n minus 2. It's going to be the total number of bunnies from 2 years ago, because all of those bunnies are going to be mature in the previous year to year n. So using this formula, I get, well, notice that 2 is 1 plus 1, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 5 plus 3, and for the next amount of bunnies in year 7, I'm going to get 13 from 8 plus 5. Let's start with a blank sheet, and let's try to do this a little further. So year, and let's do Fn. So in year 1, 1, 2, 1, 3, 2. In year 4, I get 1 plus 2, which is 3. This is what we saw before. In year 5, I get 2 plus 3, which is 5. In year 6, I get 5, 6, 7, 8. In year 7, I get 8 plus 5, which is 13. In year 8, I get 21. In year 9, I get 34, and I can keep going and going. This hopefully is an introduction to the Fibonacci numbers, Fn, which represent the number of bunnies, number of pairs of bunnies that are alive in any given year.